I'm Sebastian. I'm 14 and I go to Valley Middle School.
I'm Sebastian. I'm Sam. I'm 14 and I go to Valley Middle School.
Great. What are you showing here, guys?
So here we have a coin machine, and it was a simple one. You put in $1, out comes $1 in coins.
We removed that.
We tapped into it and we got out the 2 wires that were necessary to make it go off. And when you touch them together, it activates and it'll violently send out coins. So what we've done is we've tapped into that and we've plugged it into a relay, so it pretty much is going to touch the 2 wires together. And we have it controlled by
the Arduino.
Yeah.
We have it controlled by a Wi-Fi enabled Arduino.
Yeah,
Which hooks it up to our Mosquito and Node-RED and all those things.
So as you can see, like when we send off the messages there, this gives us money.
Great.
Our debugging is a speaker that'll read out any of the messages that are sent. So if it's not sent, we know that it's a problem on that part. But if it is sent and ours doesn't go off, we know it's a problem on this part. It all runs off a simple phone battery charger, and that lasts for quite a while. We haven't even had to recharge it yet.
Great.
3 weeks.
So when a message gets sent over MQTT, which is getting sent from where? Just any of the other stations around here? Or
Any other station disconnected.
Great.
And the other station on the same Wi-Fi network.
On the same Wi-Fi network. Great. And then also, I just sent a tweet. What happened when I sent that tweet?
When you sent the tweet, it was kind of like pressing it on the computer. It sends it to the server.
Right, based on a specific hashtag, right?
So basically, it goes through Node-RED and it looks for all tweets that have IoT Carlsbad Lab, and then through that, it sends it off to a bunch of different little nodes, and it searches for whichever one is typed in. So we typed in node 01, and it would go off to that node, which would activate this one, sending the message and activating this as if it was from a computer.
Great. And then voila, free money, right?
Free money.
We pretty much made it where you had to put in $1, and now we can just tap into it. So
Cool. Well, hey, thanks, guys. Appreciate the time.
no problem. Send that off in just a little bit.
The complexity is in security.
There's no coins in it inside, so you have to break it off.
You can wire out. And it turns into a hassle when your dishwasher is
So, is it recording?
Yeah.
Okay. So, fire this off. We said before we're going to fire it off over there. That sends off here. So when button on computer is pressed, sends here. There we are.
Yeah.
Great. All right. Well, hey, thanks, guys. Appreciate your time.
No problem.
All right. So what's next after this? What's the next steps?
After this is to create it into like a product. So instead of having this big bulky thing and like a thing that we've cut out, what we're gonna do is we're compress it into like a single circuit board PCB. Yeah.
So we cut out the breadboard aspect and make it into a PCB on there, add in the relays and stuff. Only the stuff we need. There's an extra relay on here. We can make that smaller. We can compress this down quite a bit. There's a lot of excess in here. This is just the first prototype.
Great. And how are you doing that?
By our CNC machine.
So this right here we built from a kit, and we can control it from our computer, or like we can have it designed. And what we can do is we can have it just cut out.
So it's just a little Dremel type thing. It's just on an X, Y, and Z axis, and we can control that like a 3D printer, except instead of putting it on, it'll take it away.
Right.
So it's just a little DeWalt router hooked onto here, and it'll just carve away at it at whatever we program into our modeling software.
Great. And what's the software that you're using to run the CNC machine?
We're using, I'm pretty sure, Chili Pepper currently.
Cool. Very cool. All right, guys. Thanks.
I'm Marina. I'm 12 years old. Go to Army Oaks Middle School.
And I'm Caitlin. I'm 11 years old and I go to Valley Middle School.
Great. Both in Carlsbad. All right. So what are we showing here today, girls?
So we use Node-RED to make it so that when you tweet a certain hashtag on Twitter and one of our like 20 commands, it will change the color of the light.
Okay.
So basically, what we did is, so we have this gedit with let me find it, with a ton of commands. So we have Violet, Fearless, Volcano, Blizzard, which doesn't work, Magic Sea, Rose, Robo, Melody, Veggies, Woods, Sunny, Wave, Seasons, Primary, Blossom, Fruits, Midnight, Rainbow, Arcade, and Royal. And then we have all these just individual colors. And so basically in our nude red, here, yeah. Basically what it does is, you want to explain it?
Okay, so in our node red, what we're using here is we're searching for the hashtag and the command attached to it. So here it's taking that Twitter and it's going into this change block where after it searches for the hashtag, it replaces the hashtag and the command with just the command so that it sends the lights to change them.
And the hashtag is hashtag GrayCatSC55LLE. And it had to be really complicated because to make anyone to be able to do it, basically we sort of had to like make it so all public tweets would work.
Right.
But if we did like hashtag hi,
Right.
we'd get way too many.
Exactly.
So we had to make up a really
Unique one. Unique.
hashtag.
Yeah. Unique hashtag.
Yeah. And then, so basically, this searches for the command and hashtag, cuts off the hashtag, and sends that out to the lights because they're not very smart. This actually, like, this sort of makes, like, we had at the conference thingy we went to.
Was that Saturn? Yeah.
We had a little button thingy that they could press to turn the lights a different color. So this is to code that. And this is just all our commands on a tweet, just so it actually works. So you could show you an example.
Yeah. Show us.
So it's a really long hashtag, so we just have it copied.
Right. Yeah.
Take forever. So let's change to, no, it looks like that already. Let's do Volcano.
All right. Awesome.
So that's Volcano. Normally the speakers are turned up higher so you can hear it. But we have
Cool.
if not more.
Well, hey, girls. Thanks. Appreciate it.
Stein. I go to Valley Middle School and I'm 11 years old.
Cool.
My name is Garrett Meyer. I go to Calvert Hills and I'm 12 years old.
Hello, my name is Mateo Suleimani and I'm 12 years old and I go to High Tech Middle North County.
My name is Miles Fessler and I go to Valley Middle.
Great. So what are you guys doing here? This looks like Minecraft, right?
Yeah, it's Minecraft actually, but we are hooking it up with IoT so we can control things from the real world from Minecraft. So
Okay.
for example, I could show you Chicky over there.
Uh-huh.
I could show you how to click certain buttons in Minecraft.
So what's happening here? What's allowing you to control objects in the real world from within Minecraft?
So we have a Minecraft program called ScriptCraft, and it allows us to use JavaScript to connect with MQTT. So we're running commands through Minecraft, which are connected to a server over there, and it's connecting over to this or that or any robot.
To all these devices?
Yeah.
Right. Cool.
So we can connect the BB-8. So
You can also what?
we can also connect the BB-8 to this.
Okay.
Because we made a capture the flag map. So whenever you get the flag and throw it into the place where it's supposed to, it would make the BB-8 roll.
Cool. And is it just this BB-8 or is it any of the BB-8s around here?
We can make it control two of them. Yeah, we can make control both of them. Then for the other team, their BB-8 goes the other way, so our deals kind of make like a tug of war.
Should we show them like free?
If I throw this flag in,
The BB-8 will
Wow. Okay, cool. And how about you? Anything over here that's that's going on?
We're working on a control station.
Mhm.
So you can make the BB-8 or these two machines work in unison. So basically, if I do this one, it would move forward, and then backwards, and then basically left and right. You can have like a control center.
Wow.
For the BB-8.
Very cool. All right. Hey, thanks, guys. I appreciate it.
Yeah, thanks.
Burns, I go to Valley Middle School.
How old are you?
I'm 14.
Cool.
James Ellenstein, also go to Valley Middle School, and I'm 13.
All right, great, guys. What do you guys got going on over here?
So we wrote mosquito messages to control the robots that are over here. So I'll play one. We have these all running Linux off of micro SD. They all have Wi-Fi and Linux.
Okay.
And they're booting this instead of their regular operating system.
Great.
So right when they start up, they're running a bash script. So they're looking for messages over the MQTT network.
Okay.
Checking to make sure it's for them and then running.
Great. And you loaded some of the firmware directly onto each of these individual robots?
Yeah, we mass-produced SDs. Yeah, loaded them up. the SDs in here.
Great.
And we gave them Wi-Fi chips, but these are the ones that ran it the best.
Yes.
Yeah.
Great. And then do you want to execute one of those commands over here again, like you just did again?
So, yeah, but we'll show these first. So, we can send mass commands like everyone go forward.
Uh-huh.
But then we can control individual IPs. So, I'm going to send one that I know 100 works. We can send individual. And we also created control boards, so we can just control them manually. And we have
and we label them with some mass commands as well.
Great.
So what we did,
And battery powered. So
Yeah.
everybody listening, don't throw these things out when you get them at conferences.
Yeah. So first we were trying to run these using Node.js. Thing didn't have enough space. Then we're going in every time using like a little expect script that would copy over the file and run it, so we wouldn't have to reboot every time we made a change.
Right.
And then once we got the thing finally working properly, we made the SD and we went in so it would boot every time it was running. We copied it onto a bunch of SDs, got these all going. And then the last day before the original conference, we made these controllers.
And which conference was this?
It was
Saturn?
Saturn conference.
Great.
we cooked these up by we locked some individual robots IPs,
so we could do the controller.
And we set them to we set these to only message the individual IPs, so we can control. This one and then similar to what we did in the messages over here, we would send IPs and some similar messages.
We could also control the A motors, but we didn't do much with that because none of these robots have any attachments.
Right.
So we didn't.
Maybe we could.
What's your next step on this project, you think?
So right
Looking
now,
up some more sensors and making sure they're sending out instead of just receiving.
Okay.
It means they can have the capacity to send messages out, but they're not really doing so much of that right now.
Right.
yeah, we're also going to help those guys with their SIM card or we're going to help them with their temperature sensor. We're going to send, when the temperature reaches a certain heat, we'll send a message to the speaker that's getting too hot or something.
Okay. Very cool. Well, hey, thanks, guys. Appreciate your time.
No problem.
My name is Leon Nakfor. I'm 12 and I go to Ivory Oaks Middle School. And what we're working with here is a Parrot AR drone. Using Node-RED, you can fly it. So, and Mosquito.
Oh, wow. Really took off on me.
And then using the, we also have a file which we can run this video. So,
Temperature 74.6 for it.
I got It'll take a second to load it, but well, using the camera on the drone, it can connect to the.
Temperature 74.6 for it.
So it can also go left, right.
Node 122 connected. Unread right. Unread HDR. Unread left. Unread HDR. Unread stop.
Great. And so you also have a camera connected, but right now it's,
it's just a little iffy right now.
Okay, but it's still very cool anyway. So if you were to get the camera up and running, what would you have to do here? You just run a file?
You just run a file and then open the HTML file, and that would load it. I can see if there's also
temperature 74.6 for it.
Well, there's also a file we had on a web server.
Okay.
Yeah.
Cool. So what's next for you with your project?
We can connect it to the Leap Motion. Right now it's a bit, we have it working, but the gestures are sometimes hard to, it sometimes doesn't register a different gesture, so it'd be hard to land it safely.
So what's Leap Motion? Can you explain that to me?
It uses infrared technology to sense motion. It runs.
Temperature 74.6.
Can move your hand over it. I was gonna open the diagnostics.
SSH Master, huh?
Temperature 75.09.
This is just using infrared and detects motions with it.
Great. So you could use that to actually pilot the drone.
Yeah.
Perfect.
We have a file that's working right now, but we can't debounce it. We're figuring out a way to debounce it, so it just keeps sending a message to it.
Okay.
Yeah.
Very cool. Thanks, man. I appreciate it.
Thank you.
So I'm Sam, I'm 14 at Valley Middle School. What we have here is a little Raspberry Pi. It's hooked up with a temperature sensor. We have this hooked up for a local brewery that we're
temperature 75.94.
What he basically wants is able to check his temperature without having to go to work to check on how his brew's doing. So this is our little remote sensor. We got it hooked up to the Raspberry Pi, and then it's going to go through our Wi-Fi, so we're able to do it through Mosquito. And then we wrote a little VI script.
Temperature 75.09.
Yeah, template. Yeah.
Right there. So got our VI going. That'll send the message from the temperature sensor to our IoT topic through Node-RED.
The $X is a variable it's getting from the temperature.
Okay.
Exactly. So then it'll sleep for 20.
That's colon quit.
Yeah. And it'll sleep for 20, and then it'll do that again. So if we
temperature 74.97 F.
So the temperature is 74.97 F. So it'll Fahrenheit, yeah. So it'll say that out loud, and if we have that hooked up to the brewery, we have it hooked up to Node-RED, and we can have it text him when it gets too hot or too cold.
Very cool.
Make sure his brewery doesn't go back.
Awesome. There are a lot of people that are happy you guys are doing this.
Yeah.
Thanks.
God's work.
Thanks. What's your name and age? And what school do you go to?
I'm 16. And, I go to my name is Kent Meyer. I run MCraft Systems. I'm CEO of MCraft Systems. These are kids I've been working with here on Sundays. I wanted to show you one other thing that you might not have seen in some of the presentations that the kids have done, and that is we do teach Arduino classes, and we've been kind of searching for the holy grail of Arduino kits, and so we decided to make one ourselves. This is a little ESP8266 with a cell phone battery charger, a little servo motor, and an LED, and I'm going to go ahead and turn it off. When I turn this on, it's going to boot up. It's going to run some Arduino code. It's going to connect to our Mosquito broker. You've just heard it right there, connect. and I'll be able to send mosquito messages to this node to turn on the light or turn the servo motor on. So the idea is that by teaching kids how to program with Arduino, but having them fit in to the IoT educational platform, we're now going to make it more exciting, interesting. We can have them through Node-RED, sending Twitter tweets, message passing to this. Minecraft can control this. The idea is to just have this built into a larger structure. And we're doing it all on Chromebooks that we've thrown into developer mode. We're running Crouton, and we've got the Arduino IDE up and running, controlling this. So the idea is to come up with a very low-cost way to teach kids programming with a very cheap IoT kit and Chromebooks that they might already have at their schools.
Very
That's the idea.
Very, very cool. Thanks.
Yep.